Hey everyone, it's Alan Shimel, CEO of TechStrong Group, and you're watching another DevOps Unbound. For those of you who may be new to our audience, DevOps Unbound is a bi-weekly video series sponsored by our very good friends at Tricentis, and we explore a wide range of topics around DevOps and DevOps-related technologies, practices, processes, and people. As I said, we do this bi-weekly, as every other week for those who are a little challenged. And then around once every month, we also have a live, what we call roundtable format of DevOps Unbound, where we'll have usually a little bit of larger panel, but we have a really large panel in that we open it up to a live audience, and you and everyone joining are invited to participate in the roundtable by interacting with the panel and our host, asking questions, giving us your thoughts, and it really becomes sort of a group town hall kind of meeting. When it goes right, it's great with wide levels of participation. Actually, this is a really good point that good time to bring this up. Today's panel version of DevOps Unbound is on a holistic approach to performance testing. But the upcoming or the next live roundtable, and I'm going to have more information on that later in the show, is later this month on February 24th, which is a Thursday, and it's going to feature performance testing in the cloud. I'll give you the actual title in just a bit. But one of our panel members here, Kristen, is going to be there, as well as some other great guests. You can sign up for that on DevOps.com if you go to webinars, upcoming webinars, and check it out. It's February 24th. So, and as I said, I'll bring more information on that in a little bit. But for now, let's talk about a holistic approach to performance testing. And in doing so, I think the right place to start is with our audience. I've already kind of pre-announced Kristen, so I'm going to ask her to go first if it's okay. Hey, Kristen, welcome to DevOps Unbound. Please introduce yourself to the audience.
Sure. Thanks, Alan. Kristen Webb here. I am the Director of Product Marketing at Tricentis, currently running the product line around Neoload, our performance and load testing solution. I have about 20-something years in technology. I've lost count. I've worked for a long time on the product development side. So I remember back when we were testing large software releases at Macromedia and Adobe and trying to get our products out on time as part of a broader release and making sure there was no watermelons, is what we used to call the performance bottlenecks at the end of our 3-week, mean time between failure testing. So performance testing is near and dear to my heart, as is all application development, background, and excited to be here.
Absolutely. Macromedia, that's a name I haven't heard in so long. It used to be such a big part of my workplace, and I just totally blanked on it until you mentioned that. It was like, but it brought back good memories, so that's a good thing. Yep, a smile to my face. Next up, I want to introduce you to Andreas. We call him Andy. It's Grabner, yes, Andreas?
It is, but feel free to pronounce it the way you like, as long as you call me Andy. I always make the joke, if you call me Andreas, then I typically did something wrong or rude, because my mom calls me Andreas if I did something not appropriate.
I get it. Our youngest son is Bradley, and everyone calls him Brad. And you say Bradley, and he kind of, he knows he's in trouble. But anyway, Andy, welcome. Introduce yourself to the audience, if you don't mind.
Yeah, thank you. So my first start in performance engineering was, I think, pretty much 20 or 21 years ago, maybe now. I was working at Segway Software. I was a performance tester on a performance testing tool called Silk Performer, still around. But I remember those days. And it was a large load testing project. And with my first kind of customer gig that I did. And I also remember that my performance engagement that was scheduled for 1 week took exactly 10 minutes, because we broke the system with 2 virtual users. And the virtual user was my left finger and my right finger hitting the refresh button on 2 different keyboards. And I really quickly learned that performance testing, while we always think about the magic 10,000 millions of virtual users, sometimes is as simple as just hitting refresh quite a lot on your website. Over the years, I evolved from a performance engineer. Now I'm working at Dynatrace for the last 14 years, actually, in the observability space, and I'm a self-proclaimed DevOps activist. I really like the idea behind DevOps, and I try to use channels like yours and my own channels to really advocate for what DevOps allows organizations to do in terms of tooling transformation, people transformation, process transformation. So, and I'm very glad to be here.
Excellent. Thank you and welcome, Andy. Thanks for being here. Our third panel member today is someone I've had the pleasure of knowing. I don't know, Donald, it's got to be 20 years.
It's 20 years. Yeah, it's
20 years. Was on our original team at Still Secure, what became Still Secure with Mitchell and I. But he is a developer testing person extraordinaire. I'll let him introduce himself. I don't want to embarrass him. Our friend Donald Lutz. Hey, Donald, welcome.
Welcome. My name's Donald Lutz. I've been doing software architecture for probably about 30 years. I've been focused on how to do development right, how to use design patterns correctly. The past 10 years, I've really dropped in the cloud. Right now, I'm the senior cloud and software architect at Taos. We're a public cloud company. IBM just acquired us. Frost & Sullivan rated us #1 for public cloud. We also are on the Gartner Magic Quadrant. So I'm sort of spending a lot of time helping us productize our consulting offering. So the whole idea of testing and how to do performance testing right and chaos engineering, those are really near and dear to my heart. And how do you use the right design patterns in your code to avoid all these performance issues?
Well, an ounce of prevention is worth a pound of cure, as they say, right? And we'll get to it. Our last member, though, is my co-host and friend, Mitchell Ashley. I'm going to let Mitch introduce himself, though. Mitch, take it.
Well, good to be here with everybody. Thanks for making me follow some really 3 tough people to follow. Oh my gosh. And by the way, Macromedia, Dreamweaver, Authorware, remember all that good stuff. And I've known Donald tack on another 10 years. So it's a small world. I'm CTO with TechStrong Group, working with Alan, and I also am principal with our analyst firm, TechStrong Research. So great to be here. And I think we could fill up our whole session with war stories about performance testing, Andy. Maybe we'll save that for another day, right? But good to have everybody here, and thanks to the audience for joining us.
Thank you, Mitchell. Just real quickly, I think back to performance testing. It's Still Secure, Mitch, if you remember. Broke our budget because we didn't have all the virtual, you weren't able to do it from one machine then. You actually had to go out to like a place that had enough to do a load of.
Kept Dell busy. Sending us more servers.
Man, was that crazy. Anyway, though, let's jump in. In my mind, one of the most overused words I hear in tech is the word holistic. So let's jump on that. When we talk about a holistic approach to performance testing, is it really holistic, or are we talking about, hey, what's a great approach to performance testing? How should we be doing performance testing?
I can take that to start. So building on what Andy was saying earlier about his 2 fingers being, the load test to start, I think what we mean by holistic, or just the sound approach to performance testing, is, starting with the code, starting with the APIs, starting at, one user, and making sure before you check your code in or your API in, your microservices in, that does this code work for one user? And then, as you go through your development process and you start to build the components of your application and you integrate those components, you start to hit those components with, maybe 100 or so users. And you're getting feedback along the way, so that by the time you have an application integrated within your whole system that mimics pre-production, by then you're able to, hit the load at, hundreds of thousands potentially. But you already had feedback along the way, feedback loops to say, what's performing, what's not, what do I have to fix along the way, so that by the time you get to the really high load, you have fixed a lot of the issues. And what you're fixing at the end is, what do I need to tweak within my system to make sure this application or API is going to perform? So that's one part of holistic, or we need to think of a better word. Maybe the word I tend to use is standardization. You need to cover all your bases along the pipeline, but you also need to make sure you're covering all your protocols and all your use cases. So having a standardized approach for everything from API to monolith, like we just talked about, but also what are all the protocols you're covering, from HTTP to JavaScript to SAP and Citrix, having an approach that works for all the protocols and across all those use cases, and whether it's from the protocol perspective or even the browser, because those are two different types of performance tests. But and also one that's the third thing I think about in terms of standardization is like the skill set for the people who are going to be doing the performance testing. So you want to be able to not only have your center of excellence be able to performance test, but as you move to DevOps, you want to be able to have a more distributed model for who can participate in the performance testing process, and create more of a self-service approach, so that a lot of times, if they can access a browser, they can run a performance test, they can share results. And that encompasses having, the approaches both for performance testers who want to build within CI pipelines with an as code approach or a CLI, or for the groups that want to use more of a no-code approach with a GUI tool. So those are the three things that I would say mean what we mean when we think about holistic.
Love it. Thoughts on that, team, panel? Agree, disagree? You want to add?
I wanna add something. Again, I'm not a native speaker, so maybe the word holistic means also something different to me. But I want to add one thing and then add a second thing to it. The first thing, what you said, Kristen, is I think at the beginning you said developers need to understand actually how their code is doing with 1 users and 5 and 10 and 20 users. I think what we're talking about here is people understand where are their breaking point and where are the scalability issues. Because I think if you are building new code, however small or big it is, if you put it under different sets of load, and we don't have to go to the millions of users, but if you look at it at 10, 100, and 1,000, you immediately know where are your connectivity issues between your components, and as you're scaling the load, where things may break apart and where don't they scale, right? Because obviously we can throw a lot of hardware on a problem and we somehow get performance, but at a certain cost. So I think it's very important, as you said from the beginning on, make developers understand where they may have some bad architectural decisions that will later on cost them a lot of money in order to scale this. I think that's one thing. But for me, holistic also means not only looking at it in development and starting early, but for me, holistic means I first need to understand what are my real performance goals, right? If I'm developing a new feature, a new app, I should sit down with whoever comes up with the idea and trying to get their thought on what do you expect from my software? How should it run under certain load, right? It's like our non-functional requirements in production. And then really take this and then break it down into what does this mean for me as a developer? To give an example, if we are building a new mobile app and let's say there's a feature to log in, how long do we expect the login to take? Let's say a second. Okay, if it is a second under 10,000 users, what does this mean for me as the developer that implements 2 or 3 APIs in the backend? So I think the term of a performance budget is something that I also hear and have heard over the years. So if you break down performance as we agree on with the business, if we have performance goals, and then we can break it down into more technical goals to the individual teams, then we, I think, take a holistic approach, because then everybody can really work on their component and really always make sure that their component is working and operating within the context of the performance budget that they have, so that there's a higher chance that in the end, when all the components are put together in production, we're actually meeting our business our business and our performance requirements in production. So I think these are kind of the two things, right, that I wanted to add.
Yeah, I'd like to add one thing. Well, the thing I think about a lot is because I've been building a lot of microservices over the past 10 years and thinking about synchronous versus asynchronous communication and how that plays out. Because if you have too many APIs, you have to use things like circuit breakers. There are a lot of things that can affect that. So if you start looking at things like Kafka, where do I split my workload so it's asynchronous? How does that work? What patterns do we put in there? That makes a big difference because most developers are always thinking synchronous. And I find that to be a real difficult issue because, you know what, we could put this in the background. It's, you know, it's always when you look at Amazon, just because you placed an order doesn't mean that actually went in and got billed against your card immediately. That whole asynchronicity concept has to be embedded in the concept of performance.
Yeah, true. Yeah, it's also a nice decoupling of components, right? I mean, that's the event-driven model, as you call it, right? You put a queue in the middle, but it's basically event-driven architecture and very important piece. And because the event-driven architecture also allows you to better test and also performance test components in isolation, and then also come up with better capacity planning models, right? Because you know how many events fall out of the first component when you put a certain load on it. That means how do we need to size the queues or wherever it ends up, and then what do we need on the other end to work on the queues? Yeah, I think that's a very good point.
Yeah.
Well, I think the topic is also, maybe that's why holistic is being overused, Alan. The topic has not only evolved, I think it's grown because, you know, I remember one of my first experiences working with Donald was an SMTP gateway server, a third-party product, and he was new to me, and he knew how to tune it. You know, we called it tuning then, right? But the load, the capacity, the scalability. And we've added on to that customer experience or user experience goals, metrics, you know, how long does it take to log in, that kind of thing. What's the experience to get back a response on a mobile devices versus on a web browser, whatever that might be? What's our API performance goals to partners and third-party services, things like that. So I think that's made the world a little bit more complex, maybe a lot more complex to deal with, but it also has brought us closer to what the end result is we're trying to accomplish with whatever system or software is, you know, deliver this service or make this function happen for whatever it might be, kind of help us also think across the system, you know, horizontally and vertically of what we're trying to deliver.
Yep. I think there's another element, though, that I'm interested in your all thoughts on. Liz, when I think back to over my career, how performance testing has changed, you know, what have been the big factors? Well, I think as Andy referenced early on, man, it was hardware dependent, right? Because if you wanted to scale performance testing, you had to be able to test it on the hardware it was running, and that got expensive quickly. And not only expensive for the actual cost of the equipment, but from a people perspective, right? And then, you know, the virtualization of performance testing. Wow, what a godsend. We could just have Andy here working with his, as he said, his left and his right index finger. And that was enough to break the app he was testing, or the software he was testing at the time. And, you know, and then I think, you know, with DevOps and testing and so forth, the idea of automating our performance testing, right? Being able to shift it further left into our development process, right? Because it used to be, you know, you did all your coding, and that took 1 month of your 3-month cycle, and now 2 months of that 3-month cycle were your testing cycles, right? And man, by shifting left, I really cut that, you know, out a bunch. All of these profound changes, right, are in performance testing. As we sit here today, can we say that there really is a best practices, you know, holistic or not, approach to performance testing? And what is the Where's the people part of it, right? There's always people, process, and technology. What's the people part of that? Kristen, would you mind kicking it off, or? Okay.
So I think there is some approaches that are best practices-ish. And one of the first steps is really understanding where your priorities are in your applications and where the risky areas are, because you can't test everything. So you need to really prioritize what to test first and where the issues are most likely going to come up. And two, after you do that, it's about establishing what your SLOs are, your service level objectives, and understanding, what do you need to hit within what, level of virtual users hitting that, within what time, response times, and what you want that end user experience to be like, and building those SLOs within the pipeline so that when you're running the tests in a continuous manner, you're able to say, this didn't hit the SLO when we ran it against, XYZ load, and you send that back and you have actions based on that result to, fail the build, for example, send a ticket to Jira, so that it's integrated within your already existing development process, is a good way to go about it. And then also, taking in production feedback is a good part of this too, to make sure that you're understanding what's actually going on within production, and are my tests mimicking the real world experience that my users are having under what load conditions, and making sure you're updating your Kubernetes environments to match that level of code. Do you need a new cluster based on that information that you're getting from either APM tools like Dynatrace or other monitoring tools like, Prometheus or Microsoft Monitoring, and, bring that observability data back into the test definitions, and updating them continuously to make sure you're keeping up as things change, because in reality, things do change. I mean, we have seasonality, or we have new marketing campaigns that, maybe a business that went digital, now they need to keep up with, their spikes in load. So you want to be able to stay ahead of that instead of reacting.
Agreed. Panel, thoughts?
The telemetry idea has been really the past 2 years. I've been doing a lot of open telemetry so we can know what's happening at every point. We put in Elk, we put it in Datadog, we put it all over the place, but also the whole Kubernetes cluster thing. How do you monitor it correctly? What's the right thing? There are a lot of tools that I've used, but there's the whole Kubernetes thing opens up on larger can of worms because of the way the control loop works in Kubernetes. So you have to kind of figure out how do you want to deploy them? What do the environments look like? What's the appropriate load testing there? That's why I've got into a lot of chaos engineering, breaking things in production, seeing what happens. I just turned this service off. Oh, it doesn't talk to Slack anymore. Where's all those messages going? Did we notice it's not working? That whole idea, I think, is really valuable. Surprisingly, it makes developers very neurotic. They don't like it a lot because you're basically saying, it's sort of like doing improv because we're just going to do it and turn stuff off. And they're like, well, I think it works, so it's sort of a very strange response.
It is. Andy, you're a Dynatrace, right? This is kind of right up your alley there of what you guys do.
Exactly. Yeah. And so to add what you already said, both of you already said, on a very mature scale, I think of people that I see, they just go always straight into production and maybe, using canaries or feature flags and just, deploy their new code and then expose it to, let's say, a small percentage of users. And I'm saying about the very mature, this is what we would love, obviously, more people to do, but the reality is just a small number of organizations can really do it. But that's the ideal scenario. You deploy, you use your telemetry to figure out, did that code change now? Does it actually behave better or worse than what's maybe currently out there? What I want to add, I think also what Kristen said, I think what we need to do is we need to get closer to the developers from the beginning. I know there's different terms, and I'm just throwing one more term out there, performance-driven development, because I think we've taught engineers, and I'm an engineer by trade as well, right? We've taught them over the last 10, 20 years to do test-driven development, where you write your unit tests and functional tests to cover functionality. I think we should also educate them to do performance-driven development, which means you are, as you write your new microservice that exposes 5 APIs, then write your API test that you can run once or can run continuously or with multiple virtual users to actually generate some load. And I think tools have become much more developer friendly. Kristen, again, pointing to you, I know you have a great product where you actually allow developers to define their stuff as code, right? And code could be something like YAML or JavaScript, whatever it is. But I think as the tools have matured and we are making it easier and more natural for developers to also write these types of tests, I think we will also get more adoption. I think that is very important, because we always talk about shifting left. It's a great term, but shifting left in the end, if you think about, if you take everything and shift everything left, we put all the burden on the developers. And I think this is not nothing that is sustainable. Therefore, we need to make it as easy as possible also for developers to do all the things that we ask them to do. So that means we need to give them tools that are natural to them in their habitat, which means in their IDE, right? They need to be able to check in code, and as part of their commit process, they then need to automatically not only get feedback on code coverage and functional coverage, but also, hey, your code change now has slowed down your performance by 20%. Are you aware of this? Or you're consuming 50% more memory. And by the way, and then bringing in Donald, what you said, also learning from production, then you can correlate that with your production data and say, hey, your service runs in production with a certain amount of instances. And if you are making this code change, it means you have 50% more memory consumption. Are you aware of the additional costs? So there's a lot of things I think that we need to do, but it starts with really enabling developers just to do more in their natural kind of environment that they're in. Yeah.
And I'm going to build on what you're saying, Andy, because I want to make sure I'm clear about what I mean about shifting left. And I do think it is bringing it to the developer, but as a service. So I think of it as building out a self-service rather than putting the onus on the developer to build the performance testing within the pipeline. So if it's automated in the pipeline that they're operating within, then it's really up to the performance engineer to build out, and the automation engineer to build out that testing, platform for them, so that really they're just kind of functioning, like you said, within their IDEs and within their whatever they're using to check in. And really, they're just getting a feedback once they do, so that they know how to act, in the moment, about how their code's performing for that one user to start, and then later, as they get further on, they get more information about an increase in load to a few hundred, maybe once they have, like you said, a microservice that might expose more APIs. And, once you're distributing, your code like that, how is it going to impact other code, and how is other impact code and endpoints going to impact the new code that you introduce? So really kind of delivering that. And that's what I was talking about earlier in terms of creating a self-service approach so that more people can participate in the process. But, the performance engineers are still the masterminds behind building that.
I have a question for the panel. I'm curious how do you think about this aspect of it? Part of maybe for me, a better word than holistic is systemic, kind of thinking about how all parts fit together to contribute to the performance you're delivering, as well as other things. It's not just testing our app and our app code, it's testing the whole stack vertically and variations of that, different environments that it might run in. And a lot of it's not our code. Donald was talking about Kubernetes just as one great example. Is that part of what we mean by holistic as well?
I think so. To me, one of the things I think about the holistic problem is that you get all these CI/CD pipelines built, but you don't have a GitOps process that keeps the platform aligned. You're working on that. So fundamentally, you don't have the cluster. You're not doing infrastructure as code with the cluster as effectively as you need. Therefore, when developers deploy code through it runs all the tests, but fundamentally part of the cluster didn't get So I've been thinking a lot lately in my current position, how do we get across our whole organization, GitOps deployed in all elements of our groups? So we're using that effectively with everything else we do, because that is the one piece that is happening. Argo CD is a great example. It works really well, but, just getting that to happen and realizing you're building a platform is also a thing that people need to think about.
Agreed. You know what? I just want to throw another log on the fire. So, cloud. Game changer, makes no difference. Easier, harder. Donald, you're the kind of the voice of the developer here, as well as IT. What do you think? And cloud? That you work with a public cloud provider.
Yeah, I mean,
what do you?
Public cloud is what we focus on fundamentally. That's what we're doing for all our customers. Cloud is simpler but more complex at the same time, because they're fundamentally companies are used to having their various people within their data center, and when you move to the cloud, it's upsetting. They have to figure out how to move all the workloads. But it's also one of the things that cloud gives that I've been thinking a lot about is if you can work with all three public clouds, you start increasing your reliability in everything. But how do you contain the cost? So I can run this in GCP, this in Azure, this in AWS. Companies want to go there, but they're sort of always going, how do I do that? Why do we do that? What do all these terms mean? And how do you sort of get, the various executives to understand? Because we're trying to sell them on sort of the advisory services. This is why you should do this. This is how you get your DevOps working. This is all these things. This is what you should do with OpenShift. It's a really complicated soup because, they feel like it's sort of like what happens in a lot of industry. They've outsourced it to all these people. And what are all these people doing? Are they really making a Pinto, or are they making a fancy, car? What are they doing?
Fair.
I mean, I'm curious, Donald, how you guys do performance testing for the public, but I will say that cloud is a game changer in a lot of ways, because it's not eliminating risk, right? It's just moving it from one place to another. It's shifting it from on-prem to the cloud, and also introducing new risk and new considerations that didn't have to be made before. And with auto scaling systems, sometimes people assume that moving to the cloud means that implicitly they don't have to worry about performance anymore because of auto scaling. And the concern there is that when you're in the cloud, you're really bumping up against a lot more services. And you can also run into noisy neighbors and a lot of different scenarios that will introduce bottlenecks from distributed systems. I mean, you could have your SaaS application located in France, your hardware located in China, and your middleware in a third location. And you need to make sure that a hybrid system like that is going to perform, and it can be assumed that it would just because it's the cloud. And you really need to make sure that you're, whether you're migrating apps or replatforming them, that you have a baseline of performance tests that you're measuring against to make sure that you don't regress when you move to the cloud, and that you're able to test those again once you do move there.
And I have another thought I'd like to add to that, because I've sort of done it. You run all your services in pick it AWS, Azure, or GCP. And then there's the other thing where you say, well, I want to run all my services in Kubernetes in all three public clouds. I don't really want to consume the services directly from the provider. There's some new cool APIs that are out there where I just want to consume it in Kubernetes. So you've changed the idea that your hybrid is really Kubernetes wherever it runs. So then you're not really consuming it in the public cloud, you're consuming the services through the cluster. So that also changes the whole discussion.
Maybe what I want to quickly add, and my first response to your question, Alan, was it doesn't matter because it shouldn't matter. The same with cloud native. When we talk about cloud native doesn't mean your cloud native apps have to run in the cloud. Cloud native really means how you architect your apps, and they can essentially run anywhere, right? So it's not where. Cloud native doesn't define where it runs, but how the system runs. And this is why I think also to Christian's point, you don't get let's say performance for free, or as you cannot sign up for performance as a service or for resiliency as a service just by checking a box on your favorite cloud provider, and then all of a sudden you have magic happening, right? You still need to factor all of these decisions into your architectural decisions that you make, and you have to do the proper testing in the end. I also think that the cloud was great because all of a sudden we got a lot of services that we could build upon and really focus on, let's say, business value that we could generate, because we didn't have to, invest time in, maintaining a database or maintaining your load balancers and stuff like this, because somebody took care of it. So I think overall the cloud was a great thing. From a testing perspective, to add one more thing, and I think also, Kristen, you said it again, if you have to make smart decisions where your software runs, because you always need to have in mind where your end users are, where your consuming services are, because that also means you need to test from those locations, because you may now have different latency, you may have different costs out of a certain data center, out of a certain cloud provider. I think these are some of the additional considerations. But in general, for performance and for performance testing and scalability testing, in theory, it shouldn't matter whether my application that I've architectured well runs in one cloud, in 3 clouds, or on-premise. That's kind of my answer. It shouldn't.
Alan, too, I think one of the real game changers about the cloud is just access to resources. In any organization, when you do it internally, the 2 greatest bottlenecks are acquisition of hardware and firewall rules, to be straight about it. And you can kind of control your own environment, whether it be resources or security, wherever it might be. But that flexibility gives you not just more options, you can rethink how you can automate how you set up an environment. Let's configure it this way. There's permutations, or we're thinking about changing it in some specific way, and you can automate how you test that. So it seems that it gives you a lot more flexibility. Sometimes flexibility means complexity too. Mm-hmm. But that to me was one of the biggest game changers of moving to the cloud.
Yeah, with hardware being the most expensive part of performance testing, and like you said, it's difficult and time consuming to go through IT to procure resources, to get them provisioned, to make sure you can access them at the right time and there's no conflicts. So what you're talking about really is more of the app development, app testing within a cloud CI system, which is a whole nother level in addition to, application deployment in the cloud. That's really exploding too. And it does minimize, we have with Neoload SaaS, you can get up and started and run a performance test within 5 minutes now, because it's a fully managed service using AWS and Google, and we do that for you. So it is a game changer in that way too. But also, this is where I do disagree with Andy a little bit. Like, wherever your app is, it has to perform, it has to run well. But the cloud does introduce more risk because, well, first of all, it's shifting the risk from on-prem to cloud, but it's also you're going to hit a lot more services now, particularly where you have a new architecture, where it's a modernized architecture, and it could be a what are they calling it, like a microlith now. So more services are going to be affecting you in that architecture. It could be really unrelated, and when you have that kind of a distributed system, you might not know where the bottleneck is coming from.
I think the cloud does introduce more complexity, if you will. But look, the advantages of cloud, I think, far outweigh the disadvantages of cloud, right? I think there's chips on both sides of that scale. But you know what? I mentioned in the beginning that, in addition to this pre-recorded DevOps Unbound episode, February 24th, we do have the live roundtable for our audience. So I'd like to invite everyone that's watching this, if you want to learn more about what to consider in building a cloud performance testing strategy, we do have this live roundtable. We have folks from Dynatrace and Tricentis and more joining us on February 24th the roundtable, funny enough, is called Strategies for Performance Testing in the Cloud. And if you go to DevOps.com under the webinar section, you can sign up for this webinar right there. We're calling it a webinar. It's a live roundtable. You will have a chance to have your questions answered, to speak to the panel members directly via chat, and help you with your strategy. So don't miss that, February 24th, just a few weeks from now. Guys, we're running low on time. I'd like to throw one other kind of question out at the three of you and for our audience's benefit. Right? Okay, you convinced me. I need a holistic approach to performance testing. Other than listening to the five of us on here today, can you point me to some good places if I'm in the audience where I can go find out more about this, where I can get smart quick? Donald, we let Kristen lead off everything, so if it's okay, I'm going to ask you to go first on this one.
There's a couple books I like that aren't necessarily about performance testing, but one of them, I always forget the name. It's over there, Building Microservices by Sam Newman. It's a really good book it's his second edition came out. There's another one that came out by the guys at, I can't think of where they were, but to me, that's a great reference because it covers everything from culture to how you build your microservices, how to performance test it. I like a lot of written things. There are various videos that are out there. There's a couple that Martin Fowler did that talk about this in particular. So those are kind of the things off the top of my head.
So I think Sam Newman, like Martin, were with ThoughtWorks, if I'm not mistaken.
Yeah, he's independent now. He went off on his own, and now he just
they
consults.
did leave. I remember. Yep. Andy, how about you?
Yeah. So I would say, and this is a little commercial on what we do on the side at Dynatrace, we have a holistic approach to SLOs, to service level objectives, with our CNCF project Captain, spelled KEPTN. It's a CNCF project. And what we do there, we are providing event-driven orchestration to actually embed performance engineering as part of your delivery process, but also as part of your operational processes. And there's a great integration also with Neotis, with Neoload. So that means we actually provide a framework on top of Kubernetes to enable developers to simply check in their code, and then Captain is orchestrating the deployment, the testing, like triggering a Neoload test, and then automatically evaluating your SLOs, and then pushing it forward all the way into production, but always evaluating SLOs. So always evaluating your performance criteria, your resiliency criteria, your business criteria. So if there's one thing, check out Captain, our CNCF project, because I think it will definitely contribute towards having a more holistic approach to performance engineering.
Thanks, Andy. Kristen, I saved you for last.
Thanks. So a couple things. One is we have a performance advisory council that is run through Tricentis, but really it's not about product as much as it's about approaches. It organizes all the performance, experts from around the world, including Andy. I think you participated in it a lot. And Henrik, who is going to be joining me on the webinar later in the month, used to run those performance advisory councils, and he's at Dynatrace now, so he's a great resource as well. But we have a site for the Performance Advisory Council where you can see all the recordings of experts around the world, telling their stories about what they found worked for them, and what their learnings were, and how they integrated with various development processes. In addition to that, on tricentis.com/Neoload, there's a ton of information about the problems that Neoload is addressing and how we're addressing them, the integrations we have across traditional tech stacks and the DevOps tech stack, and how we work with Dynatrace to help shift right and bring that production feedback along with all the monitoring tools for that observability. We also have a trial that's available to learn more.
I love it. Hey, Kristen, thanks very much. Again, just to reemphasize, Kristen mentioned it, February 24th, Strategies for Performance Testing in the Cloud with some really great, smart people, including Kristen. Check it out on DevOps.com. You can register. You do need to register to attend that live roundtable, though. Hey, Mitchell, I'm going to let you take it home.
Well, thanks, Alan. I was just reflecting and really absorbing what our panelists had to say today. And the thing I take away is I'm impressed with the sophistication of how we think about and the sophistication of the people who work in testing. Now, long gone are the days of testers or people who didn't like to code, right? Or developers that didn't like being developers. We've got some extremely brilliant thought leadership happening in testing, whether it be in the products that are being created, people that are trying to solve, both complex problems and sometimes fun ones too. So it's kind of a renaissance for testing time for me. It's a great time to be a tester. It's a great time to be a QA person and a software engineer working with test. So it's a fantastic topic, and I hope people will check out the resources that everybody suggested.
You're right. It is. It is. There's an old Irish proverb, may you live in interesting times or something like that. It's great times to be a tester. Anyway, Donald, Andy, Kristen, thank you so much for being on our panel today. Mitchell, as always, thank you. To our audience, thank you. We hope you found this interesting. And if you did, again, I'll beat the drum one more time. February 24th, strategies for performance testing in the cloud. Sign up for it. Don't miss it. I think it's going to be a great one. But until then, this is Alan Shimel for DevOps Unbound. Many thanks to our sponsor, Tricentis. Thanks to all of you for watching in, and we'll see you soon on another DevOps Unbound.